11.2, Statistical Studies and Sampling Methods. Again, lots of vocab, basically no traditional math. Let's get started. As you can see, starts off with these types of studies: sample survey, experiment, observational study, and then there's 3 types of studies. And you're going to be asked, which ones are these? So we got to figure out sample, which one of these sample, experiment, which one, observational, which one. So here it comes. So again, you can pause this at any time to make sure you get the information down. But I'm just going to read the definitions. The definitions might be a little confusing, but once we actually see the differences in the 3 problems we're about to solve, it'll make sense. So here's the definition. A sample survey is kind of your traditional take-in surveys. You're asking every member of a sample, so not the whole group, the same set of questions, and then you record the answers. This one, experiment, it's kind of like self-explanatory. You're applying a treatment, any sort of treatment, to a group or groups, could be people, could be animals, and measuring the effects of the treatments. Very different. And then you've got the observational, and that's kind of self-explanatory too. So observing members in a sample in such a way that they are not affected by the study. They're just going about their business and you're just observing. So let's take a look here. So it says, which of the 3 main types of study is shown in each example below? So here's the study. A newspaper polls randomly selected residents in a town about which mayoral candidate they prefer. Well, it's not observational because they're not observing, they're polling. It's not experimental because they're not applying a treatment. So almost by process of elimination, we can see it's a traditional sample survey. The sample are the people randomly selected residents, so that would be a sample. Next one. See if I can, I gave away the answer. So a grocery store wonders how many customers bring reusable grocery bags to the store. They have an employee just stand at the checkout and count the number of people, so they're not experimenting. They're not asking anyone any questions, so it's not a sample. It's an observational study. They're just observing what's going on and not affecting the people that are part of the study. And then a process elimination. This one's probably experiment. The last one's probably experiment, applying a treatment. So let's just read it. So it says the doctor conducts a clinical trial right there. There's the experiment of a new blood pressure medicine by prescribing it to half the patients in the study and measuring the effect it has on their blood pressure. So half of them don't have the medication or the clinical trial, half of them do, so that's experimental. Those are pretty self-explanatory, and you can see the obvious differences if you just think about it. All right, so what type of study could you use to answer the following questions? Does urban pollution have an effect on rates of asthma? So the study type here is observational. So you're going to observe the residents of the urban areas and then observe the non-urban residents and compare the asthma rates. So you're not applying an experiment. No experimental procedure is being done. You're just observing the differences. So that's the observational study. How many students in a school would like the cafeteria to serve breakfast? So you can see they're going to need to be asked. So this would be a sample survey, and that's the type of study it's considered. So you just ask random students and you record the results. And then a group of plants not growing well compared to the rest. What should you change to improve their growth? So you're going to pick out a group of plants and do something to them, and the other you're going to leave alone. That's your classic experimental, and it's explained right there. So hopefully you're kind of picking it up. All right, a very, very, very common word used in statistics is this word bias. And so studies that are done, the results can be full of error based on how the studies are being done. And so different types of studies create different types of biases, which creates bad results, and we're going to dive into that. So here we go. In the following situations are the differences between groups potentially due to bias. So, what is bias? Well, I explained it, but here's the definition. Any study that produces results that misrepresent a population. So let's dive in a little deeper. So, a psychologist is conducting surveys to study the happiness levels of people who live in a neighborhood. She asks the same questions to the two samples below, chosen from the population of the neighborhood. So, give me a second. Okay, so these people were surveyed, 100 people. They were surveyed in a sunny Saturday afternoon. They're not working, they got free time, 65% people happy. And then 100 people surveyed on Monday morning, going to work, only 35% people happy. They're trying to determine the happiness levels of people, generally speaking. Well, the timing of when you ask people these questions makes a difference. This is clearly biased because it's not representing people necessarily, it's representing them at certain times of day. So, in conclusion, the bias, the difference in results due to circumstances when two samples were surveyed. Sunny afternoon, 65%, that's Saturday too. And then Monday morning, 35%. Well, that's not really going to give you an accurate study of who's happy and who's not. So that's high level of bias. School wants to know the average height of the students. The school randomly chooses some students and measures their height. Some students are under 5 feet tall and some are above 6 feet, 5 inches tall. So the question is there going to be bias here? And think about it. And basically, I'll cover this up here. Bias does not affect the results here. There's just flat out, some people are tall and some are short. So there's no bias going on here at all. It's going to be a pretty accurate survey. Not perfect, but very little bias. Okay, so this next section is, in my opinion, a little confusing. So I'm going to show you this chart, talk about it just a little bit, and then show you some. I'm going to dive a little deeper into these definitions, and it will definitely help you kind of figure this out. I don't think this explains things very well, so I'm going to add some stuff to this. But it says simple random sample. Stratified sampling, what the heck is it? Cluster sampling, what is it? Systematic sampling. And then we've got high risk of bias, convenience sampling, and then self-selected sampling. So we've got 5 different types of sampling going on here, and these are simple random samples. Now, as it stands, it's not simple at all. They've got these people standing down here, and it doesn't really say a lot to me. So I'm going to add what I wrote, and we'll just talk about it. So here's what I wrote down, and here we go. So, definition. Simple random sample. Each member of the population is equally likely to be chosen. That definition doesn't help me much, but this does. So stratified sampling is, and I wrote this right here, groups of women, maybe Latinos, Muslims. In other words, after a subgroup is formed, then the subset is randomly chosen. So if you wanted to just interview women, obviously you wouldn't interview all of them. The subset or the subgroup would be the number of women you end up sampling. So that kind of explains stratified sampling. Cluster is just simple, smaller sample of a large population, not to be confusing, but this would be a good example of a cluster. But cluster, by definition, is just divided into convenient clusters, and entire clusters are chosen at random as the sample. So It's just a smaller sample of a large population. Just focus on that. It's kind of what all samples are, clustering. Now, systematic is kind of defined right here, like every third member, every 10th member, every 5th member, or something like that. So that's kind of a system. That's kind of self-explanatory. Now, convenient sampling, we've talked about a little bit, is just easy, but it's not really accurate, because let's say I wanted to get to know something about the entire Rockford High School, but I interview my first hour pre-calc class full of juniors and seniors, and I get their attitudes or opinions, and that's just convenient because it's first hour and I want to get it done with. But then my second hour, third hour, fifth hours, freshmen, sophomores, a whole different view on life. So the sample and the interviews and the questions would definitely be different depending on what hour I asked. So it'd be high risk of bias because it's just out of my convenience. It's kind of like the earlier one where the city hall member wanted to know how many pets there were, so they just walked around the city hall because it's close. But it might not be the wealthy, we haven't talked about it yet, but might not be a wealthy area, or it might be the wealthiest area, which would definitely change your study based on wealth and who has dogs and who doesn't. So it's just convenience, and it's very inaccurate, high risk of bias. And then we've got a self-selected sampling. Now that is volunteers, but here's the difference. They're being recruited by posters or emails or online ads, etc. So self-selected, it's people that are actually volunteering, but they're being recruited. It's not random. People that actually volunteer are going to have definite different mindsets than people that choose not to volunteer. You might be talking to the very highly motivated people, enthusiastic people, and not the people who aren't enthusiastic. So listen to that again if that confused you, but that kind of breaks down the simple, which I don't think are simple, random samples. Okay, so this is kind of like your homework, maybe quiz, test questions, but identifying sample methods. So really, here's some ideas, and you're going to have to categorize them based on what we just talked about. So I wish that this was on the same page as this, but we'll take care of business here and make sense of it. All right, example 3, identifying a sample method. Starting with a randomly chosen ID number. Every 5th student ID number was chosen. That's the key. And that student was asked to fill out a survey. So if we went through our list, that sure sounds like systematic. I mean, that one's pretty easy. Every 3rd member, every 4th member, every 10th member. So as you can see, that is going to be systematic. And this fits in the category of not being very biased. All right, next one. A retailer put feedback cards, meaning people have to choose to fill them out, hint, hint. They got responses from 22% of their customers. So is that going to be biased? Very biased, because those are the motivated people. So as you can see, these are self-selected people volunteering, being recruited, kind of, by feedback cards. So you can see this is an example of self-selected sampling. Only people choosing to participate are sampled. Those are kind of the motivated individuals, interested individuals. This is not random. Likely very biased. Okay, so I got ahead of myself. Talked about this just a few minutes ago. But a city wants to know what % of people in the city own a dog or a cat. A city worker goes door to door in the neighborhood around the city hall. Well, this is a city worker who works at the city hall, so they only go to the neighborhood that's really close to them. This would be considered convenient sampling because, yeah, it's really near that person. And we don't know if it's a very wealthy, affluent area or kind of a poverty-stricken area, so that would definitely change the results. And it's not a real accurate statistic about a city by just going around the city hall one way or another. So very biased convenience sampling. Okay, the final example of this lesson, 11.2, it's called randomized experiments. Well, that's the key word right there, experiment. So now they want to break it down. What's the experimental group and what's the control group? Again, more vocab that you'll hopefully get used to. And I'm going to fill this out and be right back. So, as stated before, the experimental group is the group that is receiving whatever treatment is being applied, and that can be anything. And then the control group is the group that is being controlled. In other words, they're not receiving the treatment, so they're leaving them alone. They do not receive the treatment. So that's pretty straightforward. And I'm going to write your homework assignment right on this piece of paper because it's not there yet. Okay, so again, I know you guys don't have workbooks, but I handed out copies of these pages that are necessary. So it's from your workbook, but it's what I handed you. So get to work on those. Make sure to check your answers as you go, each question, just to make sure you're on track. And check your notes and fix it and think about maybe why the errors occurred and where your misunderstandings were. But we'll talk about this more in class. So have fun, enjoy it, we're almost done.